Good evening, friends. So, in the last class, I already informed you that for 5 to 6 videos, I will devote my discussion on Zbus building algorithm, how to obtain the Zbus matrix using building algorithm. Now, in the last video, we have seen the introduction of Zbus building algorithm, how we can do Zbus building algorithm, and what is meant by a primitive network and what is meant by a partial network that we have seen in our last video. In this video, I will start with my first step in building algorithm. That first step is addition of a branch. So in the last video, I told you already that whenever an element is added between the existing node of the partial network to the new node, then we can treat such an element as a branch. Here also, I am considering this as a partial network which actually consists of m nodes, 1, 2, 3 up to m nodes, and 0. This is the reference node. This is the partial network I am considering. For this partial network, I am considering any arbitrary node in between 1 and m. That arbitrary node I am assuming as P. And I am adding an element between the existing node P of the partial network to the new node Q. Now we need to know how the bus impedance matrix will change. First of all, we need to understand how the bus impedance matrix of a partial network looks like. So this is the bus impedance matrix of a partial network. See, here we have the elements and the matrix is of the order m by m. Why the order of partial network is m by m? Because there are m buses and 0th bus in addition to that. Hence, we have the Zbus matrix of order m by m. Now, when I add an element between the P and the Q, what will happen? In the last class, we have seen that when we add an element between existing node and the new node, the order will increase. Previously, the order is m by m. Now, it will be increased by m plus 1 by m plus 1. Means the order increased by 1. So, we will have extra row and extra column. So, this is the extra row which is related to qth bus. This is the extra column. If you observe, this is ZQ1 from up to ZQM, Z1Q up to ZMQ. These are called as off diagonal elements. Similarly, this is a diagonal element. So, when we add a branch, the order just increases by 1 except the last row and the last column of the modified Zbus matrix. This matrix remains the same. If you observe, I copied the same matrix here. We added an extra row and extra column. Now, how to find these elements? Because in order to find the modified Zbus matrix, we need to find last row and last column values. In order to find the last row and last column values, we need to understand about the voltages and currents and their relations. See, E1, E2 up to EM are the voltages of the buses except reference. The voltages of the buses with respect to reference. See, E1 is nothing but the voltage of the bus 1 with respect to reference. E2, the voltage of bus 2 with respect to reference. Like that we have the voltages. Here, I1, I2 are the injected currents to the buses. So, I1 is nothing but the current injected to the first bus. Similarly, I2 is nothing but the current injected at the second bus, like that. Now we can see the relation between these voltages and the currents with the help of a performance equation. See this performance equation. This is the performance equation. So this performance equation is like this. It is E bus bar is equal to Z bus into I bus bar. So E bus bar is a vector which is a column vector consisting of all the voltages of different buses with respect to reference. I bus bar is a column of currents column vector of currents which contains all the currents that are injected to that particular bus, and this is the Z bus matrix. Now, as we added another node to the existing node through an element, I have another voltage which is at the last EQ. Hence, EQ is given and we got IQ. Now, how can I obtain the off diagonal elements and diagonal elements? There is a different procedure in order to obtain half diagonal element and diagonal element. So that different procedure is like this. From this matrix equation, I can write EQ as ZQ1I1. Is it right? ZQ1I1 plus ZQ2I2 plus and so on ZQQIQ. And we know already, as the Z bus matrix is a symmetric matrix and the elements which are connected here are linear and passive elements, bilateral elements. As they are linear and bilateral, we can get ZQI same as ZIQ. Means out of all the off diagonal elements, we need to find only the elements of last row. The elements of the last column will be obtained automatically. These are off diagonal elements. Means if you find ZQI, in place of I, we can have from 1 to M. So if you know ZQ1, it indicates you are getting Z1Q. No need to find again. If you know ZQ2, you can know Z2Q, ZQ3, Z3Q. Like that, if you find these off diagonal elements from ZQ1 to ZQM, you will automatically find these values because these are same. ZQ1 is same as this, ZQM is same as ZMQ. So the process is somewhat reduced now. And one way of finding off diagonal element is at any other bus, injecting a current of 1 ampere. See, I indicates from 1 to M. From first bus to mth bus, we need to inject a current of 1 ampere, except at the qth bus. So, why we are not adding 1 ampere of current at the qth bus, later we will see. But in order to obtain off diagonal element, what we need to do is, we need to inject a current of 1 ampere between the buses 1 and M at any bus, and making all the remaining currents as zeros. So how this will make to obtain the off diagonal elements? Now we will see that. So if you observe from this equation or from the matrix which I have written, if I inject a current of 1 ampere at any bus from 1 to M, I can get E1 as Z1I into II. Why I got only one equation? Because I injected a current of 1 ampere only at the ith bus, making all the currents as zeros. Hence I got E1 as Z1I II. It can be Z12 I2, Z11 I1, Z13 I3 like that. Similarly, how can I get E2? E2 is nothing but Z2I into II. Like that, I will get EQ as ZQI into II. See the logic here, a very simple logic which we can understand easily in order to obtain off diagonal elements of modified Z bus matrix. How can we obtain? By injecting a current of 1 ampere at the ith bus and making all the currents as zero. So, as I made current of 1 ampere at the ith bus, so II is equal to 1 ampere. If I substitute II is equal to 1 ampere, I can get E1 as Z1I. Similarly, E2 as Z2I. And we have the bus P. We know that already. So, in between 1 to M. So, I will get E suffix P as ZPI and so on. EQ as ZQI. Now, what is the meaning for this? If I want to know off diagonal element ZQI, it is sufficient if I find the EQ value, then I can easily obtain ZQI. If I know ZQI, it will automatically gives me ZIQ values. So in this way, I can obtain off diagonal elements of modified Z-bus matrix if I know the voltages. Now, from the partial network, if you observe, I added an element between the bus P and the bus Q. So we know that the voltage at the bus P is E suffix P and the voltage at Qth bus is E suffix Q. Between P and Q, I added an element, right? Is it right? Now, what is this voltage? The voltage at bus P is EP and the voltage at bus Q is EQ. So the difference between these two voltages is nothing but small VQ. Voltage difference between the bus voltages EP and EQ. Now we will see how to relate these voltages with the current between the element P and Q. For this, we need a concept of primitive network.